This lesson, we're going to learn how to draw a piecewise function given an algebraic function, or we are going to find the algebraic piecewise function given a piecewise function graph. So what is a piecewise function? A piecewise function is a function in which more than one equation must be used to define it over different parts of the domain. So let's look at an example on the right. We are going to list 3 functions that may have been used to produce this graph. So let's take a look on the most left-hand side piece. This looks like a quadratic function. And the second piece, you can see this is a horizontal line, which is a linear relation. So the equation is in terms of y equals to a number. The next one you can see is also a straight line, which is also a linear relation. But this time the equation will be y equals mx plus b. So now let's find the equation of the function now. So first piece is the most left-hand side piece. It is a quadratic function. Then we look at the vertex. The vertex is at 0, 0. So we can use the vertex form of the quadratic relation, which is y equals to a, x minus h squared plus k, where the vertex will be at h and k. From the graph, we know the vertex is actually 0, 0. That means h is 0, k is going to be 0. So I can write as a, x minus 0 squared plus 0. And I have to find what a is. So we're going to substitute a value, a point that is on the curve to find the value of a. So as you can see from this graph, there's a clear point that we can see is negative 1 and 1. So we say we substitute negative 1 and 1 into y equals to a, x minus 0 squared plus 0 to find a. And we were going to get 1 equals to a, negative 1 squared plus 0. That means 1 equals to a. So therefore, I know the first piece will be 1 x minus 0 squared plus 0, which can be simplified to y equals x squared. And now let's find the equation of the second piece, which is a horizontal line. If you extend this line, you will see the y-intercept is at 3. That means the equation of this horizontal line will be at y equals to 3. So this is the second piece. So let's move on to the most right-hand side piece now. So as you can see from the graph, this is also a straight line. And this is also a linear relation. That means it's going to be in the form y equals mx plus b. So if you extend this line, you will see the line cross over the y-axis at 0, which means the y-intercept will be at 0. The next, we're going to find the slope. In order to find the slope, you can choose 2 points on the line and you can make a right triangle. So now I'm going to find this point. After we find the y-intercept, the next one is to find the slope. So you can use 2 clear points on the line and to make a right triangle to find the right and the wrong. So as you can see from here, the positive 1 is for your wrong and positive 1 is for your right. So your slope equals the right over wrong, which is going to be positive 1 over positive 1, which is 1. Therefore, your slope is 1. Therefore, your equation for this linear line will be 1x plus 0. So we can simplify to y equals to x. So now that's filling all the information that we need. So the first piece is actually a quadratic function, which is called y equals to x squared. The second piece is a horizontal line, which is y equals to 3. The third piece is a linear relation. It's called y equals to x. However, that's defined all the domain. So for the first piece, the quadratic, they only can be on the left-hand side of the 1. And at 1, there's a solid dot. That means the restriction, the domain will be x is smaller or equals to 1. Because it is a solid dot, that means we include the 1. The second piece, the horizontal line, is between x equals to 1 and x equals to 2. But however, at x equals to 1, that's an empty dot. At 2 is a solid dot. That means 1 is excluded and 2 is included. So the restriction or the domain will be 1 smaller than x, smaller equals to 2. The third piece, as you can see, is on the right-hand side of the 2. And on 2, there's the empty dot. That means excluding the 2 and on the right-hand side of 2. So the domain or the restriction will be x is greater than 2. After we have the three pieces, now we're going to combine them into one single function. So the function will be called fx equals to, open bracket, and you will read like this, y equals, and you write down x squared, comma, x small equals to 1. Second piece, y equals, and you write 3. And 1 less than x, less equals to 2. The third piece, you will read y equals x. And x is greater than 2. And now you have a piecewise function. Example 2, this time we are given a piecewise function, and we should be able to graph the piecewise function and determine the values. Now, let's graph the first piece, which is a parabola. Y equals x squared minus 3. So the simplest way to graph this for now will be using a table of values. And let's look at the domain. The domain given is smaller or equals to -1 for x. That means my first x value I put on the table will be -1. And because smaller than -1, so I'm going to use -2 and -3. And -4. Usually, in order for you to graph a parabola, you need to have at least 3 points to make sure your graph is very accurate. And after that, we substitute the x values into the function to find the y values. So when x equals -1, -1 whole thing squared will be +1, minus 3 will be -2. And when x equals -2, -2 whole thing squared will be +4 minus 3, that will become a +1. When x equals -3, -3 whole thing squared will be +9 minus 3 will be 6. The last one, when x equals -4, whole thing squared will be 16 minus 3 will be 13. Now we put the points on the graph. However, you have to read the restriction carefully because x equals to -1. So when x equals -1, it is a solid dot. So -1, -2 is a solid dot. And -2 and 1 is also not a solid dot. -3 and 6. And -4 and 13 is way too high. So we don't need to graph that point. Just extend the line, put the arrows on. The next piece we're going to graph is the middle one, y equals to 3x plus 1. Once again, you can use slope and y-intercept to graph the line, or you can use the table values. In this case, I'm going to use from -1 to 1 because that's the domain given. And I will substitute the different x value into the function to find the y values. When x equals -1, 3 times by negative 1 is negative 3, plus 1 will be negative 2. When x equal to 0, 3 times by 0 is 0, plus 1 will be a positive 1. And when x equals to 1, 3 times by 1 will be 3, plus 1 will become a 4. And now let's look at the domain. Because at negative 1 and 1, there is no equal sign on the domain. That means at negative 1, it is an empty dot, and at 1 is also not an empty dot. Now let's graph. At negative 1 and negative 2, it's a hole, it's an empty dot. However, this empty dot has been filled by the solid dot in blue. And 0 and 1, it's a solid dot. And 1 and 4 is another empty dot. And now there is a linear relation, which is the second piece. The last piece is a horizontal line, y equals to 7. Let's try a different way to graph them. So first of all, let's graph the horizontal line, y equals to 7. And after that, let's look at the domain. The domain means x can only be greater or equals to 1. So at 1, I want you to use the solid dot. And it says x can only be greater than 1. That means we're going to erase everything that is on the left-hand side of the 1. So now this is your function. Now let's use the graph to answer our questions. F at negative 2, then we look at when x equals negative 2, where is the solid dot? Right there. So the y value is 1. F at 1 means when x equals to 1, where is the solid dot? So when x equals to 1, the solid dot is right there. So y equals to 7. And the next one is when y of the function is 1. So let's take a look. When y equals to 1, it's right on this horizontal line right there. They intersect the function at two different points. One's at here, one's at here. So this point is 0 and 1. That means when y equals to 1, x can be 0. Or when y equals to 1, x can be negative 2. So now you have two answers. So we say x will be 0 or x will be negative 2. Now, let's try a different way to graph this piecewise function. So the first thing is, we're going to look at the first piece again, which is a parabola. On this parabola, we know the vertex will be at 0 and negative 3. So 0 and negative 3, that's my vertex. And I am going to graph the entire parabola first. And it will be that and that. That. And after I have the entire parabola, and I'm going to look at the restrictions. The restriction says x can only be smaller or equals negative 1. So let's pick our erasers. We're going to erase everything on the right-hand side of the negative 1. So let's keep on erasing and erasing and erasing until x equals negative 1, and that's when we stop. And because at negative 1 there is an equal sign, that means this is a solid dot. The next one, we're going to use the slope and y-intercept to graph the second piece, which is linear relation. So y-intercept is at 1, and slope is at 3. 3 can be written as a fraction, 3 over 1. That means the rise is positive 3, means go up by 3. Wrong is positive 1, that means you go to the right by 1. So we graph the y-intercept first at 1, and slope is 3, go to right by 1, go up by 3, go to right by 1, go up by 3. After that, we make a straight line. And then we look at the domain. The domain says we only can between negative 1 and 1. So let's pick our eraser again. First, we're going to erase everything that's on the right-hand side of x equals 1. So x equals 1 is right here. So everything on the right-hand side, this region here, entire thing needs to be erased. So that's erase this part until this point, until the 1. But since at 1, there is no equal sign, so we have to change to empty dot. And next one, Cynthia again, pick out erasers. We are going to erase everything that is on the left-hand side of the negative 1. Because x can only be greater than negative 1. So erase everything here until the negative 1. And since there's no equal sign on the negative 1, we're going to use an empty dot right there. And now we're going to graph the last piece, which is a horizontal line, y equals 7. And let's look at the domain again. The domain says x can only be greater or equals to 1. So we're going to erase everything on the left-hand side of the 1. And since there's an equal sign on 1, so at 1, it is a solid dot. And now our piecewise function is complete. And just remember, please label the functions called fx. So let's make a summary. Whenever you try to graph a piecewise function, remember, you are going to graph each piece, and then by looking at the domain, you erase the part that is outside the domain, and you will have your piecewise function.